Okay, we are going to start our 5.1 notes today, which is solving systems of linear equations by graphing. And our first example is where we're going to tell whether an ordered pair is actually a solution to a system of linear equations. So I'm going to zoom in on example 1a. And what we need to do here is remember that we have an x and a y variable. And what we're going to do is we're just going to plug these in for the corresponding x and the corresponding y, and then see if it actually works. We're going to do this for both equations. For this to be a solution, though, we need to make sure that we have to test the ordered pair, and it must work for both. Must work for both. So here we go. Let's zoom in on this first one, and let's go ahead and try this. So I'm going to, for the first equation, I'll call this equation number 1, 2 plus 5, and we want to check, does that equal 7? 7 equals 7, so that works. Excellent. And then what we're going to do is we're going to have equation number 2. We're going to do the same thing, 2 times 2 minus 3 times 5. Does that equal negative 11? So I get 4 minus 15. That's negative 11, which equals negative 11, and that works. So our answer here is yes, 2 comma 5 is a solution. All right, let's go ahead and go over to example 1b. We'll do the same thing here. We'll have equation number 1. So let's go ahead and do that one. 0 equals negative 2 times negative 2 minus 4. So we want to know, is 0 the same as, well, negative 2 times negative 2 is positive 4. 4 minus 4 equals 0. So that one worked. Let's go ahead and do equation number 2 now. So 0 equals negative 2 plus 4. Is 0 the same thing as negative 2 plus 4 is 2? That is a no. So our final answer is negative 2, 0 is not a solution. All right, so what you can do right now is there are 2 on your owns that you can go ahead and do. So go ahead and pause the video, and then I will tell you the answers. All right, welcome back. So I don't want to take up too much time, but what we have here is this first one would be a no, it's not a solution. And then number 2, the answer you should have got a yes, it is a solution. All right, so let's go ahead and go to the next page of our notes. And there's a little core concept here. And so we did say this section is about solving systems by graphing. So the first step is we need to graph each equation in the same coordinate plane. I'm going to add a little note here. So to be accurate, I want you to use your slope-intercept form. All right, we're not going to graph using intercepts. We're going to graph using slope-intercept form. So let's go ahead and look here at example number 2. It says solve the system of linear equations by graphing. Notice these are already in slope-intercept form. So I'm going to maybe use this one, this first equation, as a red one since I have different colors here. And I'm going to identify that my y-intercept is 5 and my slope is negative 2 over 1. So I'm going to go up to 5. 1, 2, 3, 4, 5, and put a point there. And then my slope is down 2 over 1. And I'm going to keep doing that as many times as I can, because when we're graphing systems, we want to be super accurate. And then when I get to the end, I'm going to go backwards, so it'd be up 2 and to the left 1. And after I have those dots, then I could go ahead and you would use a ruler. I don't have a ruler here on my tablet. Put that arrow. So there's the equation, the line for that equation. Now I'm going to go ahead and do the next one. I'm going to use blue on this one. This one has an intercept of -1 and a slope of 4 over 1. So I'm going to start -1, and the slope of 4 goes up 4. 1, 2, 3, 4 over 1. And as soon as it crosses another point, circle that. And let's write down the ordered pairs. 1, comma, 1, 2, 3. So this is supposed to be the point 1, comma, 3. We're going to test that here in a second. As soon as we have that, you can go ahead and use your ruler and connect these just so you can see what the line's going to look like. Yours will look much nicer than mine. And so this is supposed to be our solution here. So I'm going to mark this as my solution, but I do want to check it. So just to make sure, I'm going to check this back in the original. So does 3 equal -2 times 1 plus 5? -2 plus 5 is 3, so 3 equals 3. That works. And then I'm going to go in the next equation. I'm going to put in 3 equals 4 times 1 minus 1. So 4 minus 1 is 3. That worked. So we're just checking it. All right, so 1 comma 3 is correct. Let's go ahead and skip down to the on your own number 5. Let's start this one together. First thing is we need this in slope-intercept form. So this first equation, if we look at it here, it should be written as y equals -2x plus 5. What I did is I just subtracted 2x from both sides. Now the second equation, I want this in slope-intercept form as well. So the first thing is I'm going to subtract 3x from both sides. And I get -2y equals -3x plus 4. Divide everything by -2. And I'm going to get y equals +3 over 2x minus 2. So those are the two equations that we need. Here's our second equation, and then here's our first equation, and those are what we're going to graph. So what I want you to do is to pause everything right now, and I want you to try these 3 on your own, and then I will quickly just tell you those intersections. All right, now that you're done with that, I'm going to tell you the answers to these. For on your own number 3, it should be 3 comma 1. For number 4 is -4 comma 1. And for number 5, it is 2 comma 1. So those are your 3 answers. I didn't put the graphs on there, but that's what you should have. And we're going to skip example number 3 because we are going to have our own word problems lesson day. So that's all for 5.1. And if you have any questions, feel free to reach out and ask for help.